Hello, welcome to everyone in this video. Today we want to discuss about the question solution of CC10, which consists the quantum mechanics for University of Calcutta 2021 question for semester 4 in physics honors. So if you want to watch the another previous year solution of Calcutta University physics honors, you can go to the description box. There is a link of playlist, you can go through this one. And there are various video regarding the physics theoretical part and problem solution. You can also go to this channel. You will be get different playlist for different portion of theoretical part and the problem solution. You can go through this also. So let's start today's discussion. This is the total question paper. I request all of you try to solve this question yourself at first, then continue the video to watch the solution, right? So this is one A, B, C, D, and then E, F, G, and after that two A, B, C, three A, B, C, four A, B, C, D, five A, B, six A, B, and then 7 ABC. So this is the total question which asked in 2021 of semester 4 Calcutta University Physics Honors, right? So you try first to solve this question, after that continue the video towards the solution. First question says, how many lines of spot of detecting screen will produce in Stern-Gerlach experiment is performed with an atom or total angular momentum J. That is, the total angular momentum is J. What will be the total number of lines? This will be 2J plus 1. This is a very simple question. I don't know why this gives you 2 marks. This is a just theoretical portion. This is the answer. Okay. This is a book page. I just refer to this. This is a simply theoretical question. Next question. The wave function of a particle of mass m in one dimension of potential. This is the potential energy has this is the wave function in the ground state, where a is the normalization constant and alpha is positive constant. Making use of Schrödinger equation, find the ground state energy of the particle. So this is the wave function. Take this first derivative and the second derivative with respect to x, and this is the potential. Use this Schrödinger equation, time independent Schrödinger equation, that is minus h cross square by 2m, this 2 psi by dx square plus v psi equal to e psi. Put this value of the 2 psi dx square and the value of v, you just give, you will be get the value of e. Very simple. I think you clear about the solution. Next question. In the ground state of harmonic oscillator, calculate the probability of finding the particle outside the classically allowed region. Think, in classically you know the energy distribution will be like that. The wave function will be like that between minus a to plus a in the classical oscillator. But in quantum mechanically, this will be the total distribution minus infinity to plus infinity. So the question says that is the probability to finding the particle outside the classical allowed region. So this is the classical allowed region. Outside this region you need to find out. Okay. So this is the classical allowed region mod x less than a, that is minus a to plus a, where the potential energy is E. So if you equating these two, that is potential energy is total energy, you will be get this value of a, that is the limit. Then the probability to finding the particle within that region will be like that, psi star star, and limit will be minus a to plus a. Okay, and just coefficient here, this multiply the coefficient. This is the ground state wave function of a harmonic oscillator. This is ground state oscillator. So just multiply this one and put this value of this one, and in taking this as a t and just integrating, this function will be obtained. So put this value. So this is the probability within that region. So outside that region will be the 1 minus this. So nearly 0.1573. Clear? Next question. A free particle does not has defined energy. Free particle means there is no potential energy, that is V equal to 0. So put this V equal to 0 in Schrödinger equation, you will be get this relation, and this must be giving this energy, this wave function, and here you can see this k is not a definite value. so the energy will be also not definite. Next question. Evaluate Lx square plus Ly square, comma Lz square, where Lx, Ly, Lz are the components of orbital angular momentum operator. So these can be expand like that, just additive to things. And this is a commutative property. Put this commutative property, will we get this two term, and for this two term, this property a b comma c equals to a b comma c plus a comma c b. Okay, after that you know this relation lx lz means minus ih cross ly. Okay, so put all commutating value and you will be get the 0. So this value will be 0. Next question. If parity operator satisfy this equation satisfy a parity operator, P has only two eigenvalue, so that P has only two eigenvalue, and find the eigenfunction each. So this parity operator operates to this one. So if you again operate parity operator on that, you will be get the same function. So P square equals to 1, so P is plus minus 1. So its eigenvalue is plus 1 and minus 1. And the corresponding eigenfunction will be like that. One is psi of x and this is minus of psi. This is the even parity and this is the odd parity. Next question. So that all the inert gas term symbol is like that. So for inert gas there is total ml will be 0 because this is full field. In inert gas the total electrons are outermost cell of electron are full field. That's why total summation of ml, that is the orbital angular quantum number, angular moment quantum number is 0, and similarly spin angular moment quantum number will be also 0. So total L is 0, S is 0, so 2S plus 1, that is multiplicity, which one, and J equal to L plus S, which is 0. So you will be get the term symbol, that is 2S plus 1 Lj. So this is 1, L is 0, that's mean S, and J is 0. So that for inert gas the symbol will be 1S 0. Next question. Question says a particle of mass m confined with this potential energy. This is the potential energy. Using this eigenfunction and the energy value of harmonic oscillator, find the energy eigenfunction and the energy eigenvalue. Here you can see for x greater than 0, this is v of x. So like that parabolic, and this minus less than 0 minus infinity. So you can see this is the half parabolic potential. If you take total, so you will be get total parabolic potential. This is a half parabolic potential. So you can think this is the half harmonic oscillator portion of harmonic oscillator. So this wave function must be continue everywhere. So if you take this total wave function, this will be like that. So for that you will be get this relation, but you must satisfy the boundary condition that it's continuous everywhere. Since this is at x equals to 0, this becomes infinite, so psi must be 0. So at x equals to 0, psi must be 0. So psi nx equals to like that. In the above expression, psi x equal to 0, the only h nx is term is that mean we need to 0 at x equals to 0. So this can be 0, only this term can be 0. So we just plot some value of hn alpha x, where alpha takes this constant. So n equals to 0, this is 1. So at x equal to 0, this is not equal to 0. For n equal to 1, this is 2 alpha x. At x equal to 0, this is 0. For n equal to 2, at x equal to 0, this is not 0. For n equal to 3, at x equal to 0, this is 0. So you can see the alternative becomes 0 at this. So these alternatives are satisfied. That means n equals to 1 satisfy, n equal to 3 satisfy, and n equals to 5 dot dot dot. So odd number are satisfying this boundary condition. What is the boundary condition? That is at x equals to 0, this must be continuous. Continuous means at x equal to 0, this is infinite. So psi, the wave function must be 0. So at x equal to 0, psi wave function is 0 when this is equal to 0, and this equals to 0 at x equal to 0 when this n value is odd. So we take this odd value, that is to n equals to 2p1, 2p plus 1, that is the odd value, where p equal to 0, 1, 2, 3, etc, etc. So psi p x equals to like that. Just put this value n here, we put the value of n, as the 2p plus 1, just putting this value, and just change the nth, sorry, just replace the p as a n, just this notation, just you will be get this function, and the corresponding energy value, you can see here the energy is n plus 2 half h cross omega, so n is replaced by 2n plus 1, n is replaced by 2n plus 1. So this is the energy value and this is the corresponding wave function when x greater than equals to 0, and when x less than 0, this wave function is 0. There is no wave function in this left hand side. Okay, so the only wave function is right hand side. I think clear about the solution. If there is any doubt, you must comment in the comment box. Next question. Draw the ground state and the fast excited wave function along the potential of the particle. So you already find out the wave function and the energy eigenvalue. Just put this value n equals to 0 for ground state. You will get these two relation, and for excited state n equal to 1, you will be get this relation. And the plotting of this curve will be like that. This is for n equals to 0. This is for ground state. This is for n equals to 0, and this is for n equals to 1. Ground state. This is for ground state, and this is for first excited state. Okay, next question. The particle in the above potential starts out in the state psi x is given like that. This two wave function, psi 1, psi 2 ground state and fast excited, which is already obtained in the particle respectively. Calculate the energy expectation value. So we just know the energy expectation value of ground state and fast excited like that. We previously obtained here taking these two value, and the expectation value of energy of this state is nothing but the 1 by 5, 3 by 2 plus 4 by 5, 7 by 2. 1 by 5 is arise from this square. Actually, this formula expectation value of energy is summation ci square lambda. So summation ci square, this coefficient square is 1 by 5 and this is 4 by 5, and their energy is 3 by 2 h cross omega and 7 by 2 h cross omega. So finally, you will get the expectation value like that. Okay. Next question. At t equals to 0, a free particle described by following Gaussian wave function. This is the Gaussian wave function where t equal to 0 is where is a constant or simple as their usual meaning. Normalized wave function. You know at normalized conditions psi star psi is dx equals to 1. So you just put this value psi star psi, the exponential I component will be vanished because one is star and another is non-star. So these are vanishes, you will be get this relation, and this is even function, that's why this limit change 0 to infinity, and this is 2. And you know this is a gamma formula, that is 0 to infinity e to the power minus b x square x to the power n dx equal to 1 by 2 b to the power n plus 1 by 2 gamma n plus 1 by 2. So here you can see there is x to the power 0, so this is 0 plus 1 by 2, 0 plus 1 by 2. So you will be get this is half, so this is sigma naught, and this is gamma half is root pi, so you'll be get a is like that 1 by root under sigma naught root pi. Put this value of a, you'll be get this wave function. Normalized wave function. Sorry, find the wave function in momentum space. So this is the normalized wave function in space, position space. Now you need to convert into the momentum space. From position space to you need to change into the momentum space, just taking the Fourier transform. From position to momentum you need to convert using the Fourier transformation. Okay, so using this Fourier transformation, this transformation will be 1 by root under 2 pi h cross minus into plus into psi of x is. So put this value of psi of x, you will be get this relation, and taking this as very carefully, you just taking the integration using this integral formula. This is very helpful integral formula. You just remember this integral formula and you can easily find out this integration. The integral formula says e to the minus ax square plus bx dx equal to root under pi by a e to the b square by 4a. So here this is a and this is a b. So 1 by root under pi by this e to the power b square. So this is square by this. So you just calculating this one, you will be get this wave function in momentum space. Okay, just throughout this calculation I just refer to your step, you can do this calculation very easy. Next question, hence find the expectation value of p and expectation value of p square. So expression value of p is like that. So put this value of phi of p, you already obtained here, and putting this value and taking this as separate out, and put this gamma integral formula both side, you will be get this answer. In case of p square, you the same value, put this phi of p and separate out this whole square formula and separate out. You can see this is a odd function with the p1 here, so this is odd function, so this becomes 0 because this limit is minus into plus into, and this two gives you a gamma function. You will be get this value will be like that. Okay, you calculate this expression, very easy, and do yourself actually. Okay, next question. The normalized wave function of a Gaussian state of hydrogen atom will be like that. Calculate the most probable distance. Most probable distance means the probable distance, finding the particle is between r and r plus dr equal to like that. So the most probable distance, this must be will be derivative will be 0. First derivative will be 0. So just taking this first derivative with respect to r, you will be get this relation. After that, you will be get this value of r. This is the most probable distance. Next question says calculate the average distance. So average distance means expectation value of r. So this is psi star r psi, and this in the spherical polar coordinate system dv is 4 pi r square dr. So just taking this integration, you will be get the, using this gamma function, you will be get this value. Okay, so this is the average distance of this electron. Okay, you can do this integration very well, no problem. Next question. Sorry, sketch the radial probability distribution of pions. So probability distribution is psi star psi d of is 4 pi r square dr. You will be get this value, and which is 1. So the probability will be 1 with respect to r. Next question. Calculate the average value of modulus of Coulomb force acting the electron. So the Coulomb force will be like that, and the modulus value is nothing but this. This negative is omitted, just value. You will put this value and integrating, you will be get this answer. Okay. Next question. Sorry. Sorry, psi theta comma phi is given here. This is a function, you need to find out a. So this spherical harmonic 1 minus 1 is like that, and 1 comma 1 will be like that. If you added this thing, you will be get this one. So just for normalization, psi star psi theta equals to 1, put this value taking into to 1, and this is in the surface area volume 1, and just calculating these things, integration 4 sine cube theta and 2 sine square theta, integrating, and theta is 0 to pi and phi is 0 to 2 pi. This is the value of phi. Phi is 0 to 2 pi and theta is 0 to pi. So you will be get this integral value, that is 1 by 2. Okay, is this function is eigenfunction of this? So just put this L square of this function, you will be get this one, and this is nothing but the L into L plus 1, so you will be get this one. So this is the eigenfunction. Is this is eigenfunctions of Lz? So Lz of this one is m into h cross this one. So just put this value, you will be get, does not is a function of psi, so this is not a eigenfunction. Next question. Calculate L square Lz expression value of this. So L square of expression value of this one. So put this value of L square here, psi star psi, and the L square on psi is nothing but 2 into this one, because we just find out here L square into psi equal to 2 into psi. So this is nothing but 2 into psi. Integrating, you will be get this one, and Lz. So you will be get value of Lz is minus I square del del phi. So just taking this partial derivative and integrating, you will be get 0. Next question. Alpha plus, which is given as 1 0 half half, and alpha minus is half minus half, two eigenstate of spin of particle. The x component of spin operators Sx is given like that. Find the normalized eigenstate and eigenvalue. For eigenvalue, you know any matrix Sx minus lambda equals to 0. Just put this value, you will be get lambda equal to plus minus h cross by 2. These are the eigenvalue. For lambda equal to h cross by 2, you just put this value. is x minus h cross by 2I, just method we use in finding the eigenvalue eigenstate in matrix. So just Sx equal to like that, so we will get this one, and so x1 equal to this. For normalization 1 by root 2 this one. Similar for that one, we will be get the normalized value this one. So this is the normalized eigenvalue and eigenvector. Next question says express any general state of spin-up particle is like that linear combination of eigenstate of like that. So we take this linear combination of this one, these two eigenstate C1, and just multiplying will be get this one, and comparing these two we will be get this value of C1 and C2, put this value of C1 C2. So this is the linear combination of this one. Next question. Alpha and beta, alpha ket and beta ket are two states of spin-up particle. Obtain the normalized triplet and singlet spin state of spin-up particle. So here these two states, alpha and beta. So here mh equals to plus minus h cross by 2. So for h cross by 2, take this is a spin-up as a up alpha, and minus h cross by 2 as a down, take as beta. So there are possibility two particle will be like that. One is alpha, two is alpha, one alpha, two beta, one beta, two alpha, one beta, two beta. Okay. So up, down, down, down. So for this one, if you just add it, up 1, down 0, down up 0, and this is minus 1. For each, for total spin S equal to S1 plus S2. So this is 0 and this is 1. For S equal to 0, multiplicity is 2S plus 1, that is 1, that is singlet. So the singlet will be like that, and for S equals to 1, the multiplicity 3, that is triplet. So 1, 1, this 1. So you can check this is a antisymmetry and this is the symmetry. So this is a triplet and this is a singlet. You can check this as a normalized, that is unit. So this singlet is normalized. This do not required. We just verify here whether this is normalized or not. So taking this singlet straight and the square. So this square, square, and this is minus 2 in this. This is so gives you 1. This is gives you 1. This gives you 1. But this gives you 0. Finally, we get this 1. So this is normalized. Similar for this triplet also, we just prove this is normalized, this is not required. Next question says, consider the finite square well, this is phi of x equal to like that, where v0 equal to 2a and v is the width. Derive the transitor equation of determining the discrete energy of eigenvalue of symmetric wave function bounded state. So there is the potential barrier with the lower value is this is equal to minus a to plus a. This is bound state. So for region 1, this is v equal to 0, this is v equal to 0, and this is minus v naught. So this three region wave function here, and at the boundary condition at x equal to minus a, this function and their derivative must be continuous. And similarly at x equal to minus a, these two are continuous. This is x equal to minus a and this is x equal to plus a. These two are continuous, and obtaining relation between B and C, and this is relation between B and C, will be get this one. This is actually the wave function. This is symmetry and another one is asymmetry, and from there you will be get this relation, and this is the actual phenomena relation, you will be get this one. And in the next question which says about that the find the energy eigenvalue of the symmetric wave function. So previously we obtained this relation from here. You can see here we take this alpha a as a xi and ka is a eta. Will we get these three relation, and taking these two relation you will be get this value of eigenvalue like here. Actually this is solved by graphical method. There is tangents from will be like that, and there is intersection, it gives you the solution. Next question says, consider the Schrödinger equation, this one for two particle system where v is the function is r, which is r equal to r1 minus r2. So that this can be written as like that, where m equals to m1 plus m2, r is the center of mass position, small r is their separation, and mu is the reduced mass. So r is r1 minus r2, center of mass position is like that. And this psi, which is function of r1 and r2, can be changed into r in comma capital R. Capital R is the center of mass position, small r is the separation of this r1 minus r2. So this operator 1 can be written as like that, del psi by del r1 vector, and this can be changed into r and small r in r and capital R. That is del psi by del small r into del psi by del small r 1 and del psi by del capital R into del capital R by del r1. So this is nothing but del grad r, and del psi r by del r1 you can check, this is 1 and this is grad r, and from here you will get del r by del r1 equal to m1 by m. So del 1 is equivalent to this one. Similarly for del 2, del psi by del r2 equal to del psi by del r into del r by del r2, just function of r and capital R, and this is nothing but minus 1. Del r by del r2 is minus 1, and del capital R by del r2 you can see m2 by m2 by capital M. So this is grad 1 and this is grad 2, these two are functions. So grad 1 square by m1 plus grad 2 square by m2, put this value in grad 1 square, so this is the whole square, and 1 by m2 grad 2 square, so this is the whole square. To put this whole square formula, so this is square and this is square and 2ab, for that one this square, that square, and minus 2. So these two are cancel out. From this to one you will be you can take this common, m1 plus m2 is m, and this is mu is nothing but m1 m2 by m1 plus m2. So this is equivalent to that one. Now the given expression is like that, just put this delta 1 square by m1 plus delta 2 square by m2 replaced by this thing, you will get required answer. Okay, I think clear. If there is any doubt you must comment in the comment box. Next question says, considering the spin orbit correlation term, that is this one, this is S for spin, O for orbit, H1 atom, is written as like that, S dot L equal to this commute, so that this is commute like with that. So L square into this, so this is nothing but K into L dot S dot L. So K is taken as common, you will get this one. S dot L means Sx Ly plus Sy Ly plus Sz Lz. So just taking this as a common. So finally you will be get taking this relation, using this relation you can separate out this one. You know this are 0, so this is finally 0. Next for a square, the similar things, you will be get this relation, and this is in 0, so this will be 0. Okay, similar things. For j square, j is nothing but L plus S, so L square plus S square plus 2 this. So L square, this one 0, S square, this one 0, and these two are similar, so this is also 0, finally 0. Next is ZZ. ZZ equals to LZ plus SZ, and this is like that. So just separate out, you will be get 6 term, and this is using this formula, you will get that one. And you can see this is IH cross LY, this is 0, this is minus IH cross LX, this is 0, this is 0, and just carefully you just put this value, you will be get this one, and finally you will get 0. Since this is 0, so these are the commute with like that. So this is commute with L square, S square, J square, and LZ. Okay, but it does not commute with LZ or SZ. We can prove that also. Next question says, find the Landesi factor 2p 3 by 2. Since this is p, so L equals to 1. 2, that is 2s plus 1 is 2, that is s equals to half. 3 by 2, that is j equal to 3 by 2. You know this term notation. So Landesi factor g equals to 1 plus j into j plus 1 plus s into s plus 1 minus l into l plus 1 by 2 j into j plus 1. So just put this value of j, s and l, you can easily find out this is 4 by 3. I think clear, you just go through the calculation yourself. If there is any doubt after that, you must comment in the comment box. So this is all about me, and this is my contact detail. You can connect me with this Telegram channel. This is my online platform. And this is my YouTube channel details. Go to this channel, you will be get defined field related videos, some mathematics. Like this session, if you learn something from this session, share this video to your friends, either he or she also get benefit from the video. Subscribe this channel if you need this channel, just already subscribe. Thanks for subscription. Press the bell icon to get notification of upcoming videos. So take care. We'll meet you in the next video as soon as possible. Thank you.